All right, let's talk about the brain inside all your favorite gadgets. We're going to pull back the curtain on what makes them tick. And we're talking about the big three, the CPU, cores, and threads. Let's dive right in.
You've seen it, right? You're looking at a new computer, a new phone, and you see that spec sheet. 8 cores, 16 threads. It sounds really impressive, but what does it actually do for you? Well, stick around, because by the end of this, you're going to know exactly what that means.
Okay, let's start with the big boss, the CPU, or the Central Processing Unit. Honestly, the easiest way to think about it is like the head chef in a really busy kitchen. It takes all the orders, which are just instructions from your programs, and gets them done. It's the one in charge of making everything happen.
Now, way back in the day, CPUs only had one single core. Imagine that. It's like having just one chef trying to cook an entire banquet. They're running around, switching between dishes like crazy. It works, but it's not super efficient. Today, pretty much everything is multi-core. This is like bringing in a whole team of chefs. Suddenly, you can have 4 chefs working on 4 different dishes all at the exact same time. That is true multitasking.
So, what exactly is a core? Well, you can think of it as its own miniature brain. Seriously, it's a complete processing unit. It's got the part for doing all the math, some super fast memory for what it's working on right now, and a control unit that basically acts like the foreman for that little operation. It's a self-sufficient worker inside the bigger CPU.
And this is where we get to threads. A hardware thread, which you might know as hyperthreading, is a really clever bit of engineering. Let's go back to our kitchen. If a core is a chef, then a hardware thread is like giving that chef 2 hands. So while one hand is waiting for the water to boil, the other can be chopping vegetables. It doesn't make the chef twice as fast, but it makes them way more efficient. No more wasted downtime.
But hang on, this is where things get a little tricky. And honestly, it's where a lot of people get confused, because the word thread doesn't just mean one thing. And this is absolutely the most important thing to get. We have to draw a line in the sand between 2 very different kinds of threads. What we just talked about were hardware threads. The 2 hands for our chef. That's a physical feature built right into the CPU. But then you have software threads. Your applications are constantly creating these. Every single tab in your web browser, that's a software thread. The spell checker running in the background, yep, another software thread. They're basically just to-do lists for your computer.
So you have all these software to-do lists, and only a few hardware hands to do the actual work. How does that work? That's the job of your operating system, your Windows, your macOS, your Linux. It acts as the ultimate project manager, grabbing all those software threads and assigning them to a hardware thread that's free. Which brings up a really cool question. Think about it. You might have hundreds of programs and background tasks running, hundreds of software threads, but your fancy new CPU only has, say, 8 cores and 16 hardware threads. How on earth does your computer not just grind to a halt? How does it create this illusion that everything's running smoothly at once? Well, the magic behind it is a little something called the OS scheduler. Think of it as that hyper-efficient kitchen manager, clipboard in hand. An application creates a task, and the scheduler instantly grabs it and says, okay, you go to chef number 3, he has a free hand right now. But, and this is key, it only lets it run for a moment. This whole juggling act is called time slicing. The scheduler gives each task just a few milliseconds of the CPU's attention before, bam, it swaps it out for the next one in line, and the next one, and the next. It does this thousands and thousands of times every second. It's so fast that to our slow human brains, it just feels like everything is happening simultaneously. It's a beautiful illusion, really.
Okay, so it's settled. The answer is just to cram as many cores and threads into a CPU as possible, right? More chefs, more hands, always better. Well, not quite. There's another really important number on that spec sheet we need to talk about.
And that number is clock speed, the thing measured in gigahertz, or GHz. So if cores are the number of chefs you have, clock speed is how fast each one of those chefs can work. A CPU with a 4 gigahertz clock speed means each core can perform 4 billion cycles per second. For certain jobs, having one ridiculously fast chef is actually better than having a bunch of slower ones.
So what should you be looking for? It really depends on what you do. If you're a big gamer, a lot of games still rely on the raw speed of a single core, so for you, a higher clock speed can mean a higher frame rate. But if you're a video editor or a 3D artist doing work that can be split into a million tiny pieces, oh yeah, you want more cores. All the cores you can get. For just browsing the web and doing everyday stuff, you're going to want a nice balanced approach.
All right, let's wrap this all up with our kitchen analogy one last time. The CPU is the kitchen. The cores are your chefs. The hardware threads are the chef's two hands, always keeping busy. The clock speed is how fast each chef is chopping. And your operating system? That's the super efficient kitchen manager, making sure every single order gets taken care of. Pretty simple when you put it like that, right?
And that's it. Now you know. You're not just looking at numbers on a box anymore. You understand the team of workers you're hiring to run your machine. So the only real question left to ask is, what kind of kitchen do you need to build? What's the right brain for your machine?